Okay, we're going to find out if the series converges or diverges. So we can use the alternating series test. The alternating series test has two conditions. So first of all, we have b sub n being whatever is this series minus this, minus the part which determines the alternation. So b sub n would be this. And we have also b sub n plus 1, where we plug in n plus 1 wherever you see an n. And it has to be less than or equal to b sub n. That's the first condition of the alternating series test. The second condition is that when you take the limit as n approaches infinity of b sub n, this equals 0. And this will guarantee that this series converges. So that's why we need our two conditions. If it passes these two tests, then this is called the alternating series test as a whole, and then that will tell you if this converges, or it'll tell you if it converges. If it doesn't pass the tests, then it's inconclusive. It doesn't tell you automatically that it diverges. So these are only if it passes both of these levels, then it converges. Otherwise, it doesn't tell you if it converges or diverges. So let's try our first thing right there. b sub n plus 1. Is it less than or equal to? So that would be e to the negative n plus 1. Is that less than or equal to e to the negative n? Well, this is equivalent to this, and this is equivalent to this. So is that less than or equal to? Well, clearly it is less than or equal to, because it's less than. I mean, if you plug in numbers here, you're going to have a larger exponent, and a larger exponent in a denominator is obviously going to give you a smaller term than whatever you have over here. So it does pass the first round. The second round was if the limit as n approaches infinity of this equals 0. Limit as n approaches infinity of this equals 0. So let's take the limit as n approaches infinity of e to the negative n. That means we plug in infinity into that. And remember, this is the same thing as this. So we're plugging infinity into an exponent in a denominator. So 1 is being divided by infinity. That would go to 0. So yes, it passes the second round. And therefore, this thing converges. It converges by the alternating series test.